didn't miss anything. Okay, so I want to come back for a second to those two possibilities with an even index and with an odd index. And I said that this is excellent because I can have positive, I can have zero, I can have negative. And the answer is positive, zero, or negative. No problems. No problems whatsoever. I love this. This one is an issue because first of all, it can only have positive or zero underneath, and the answer has to be always positive or zero. Well, of course, unless there is a minus in front, but that's a different story. So anything like the fourth root, the square root, the sixth root, the quantity underneath has to be positive or zero, and the answer has to be positive or zero. Mandatory. So when I write x, I see it's a radical, so then the power of x has to be a fraction. And now we have to identify the numerator and the denominator. Can anyone help, please? Anyone? It's okay if you're wrong. At least I know you're following and you're here. That's all I care about.
12 over 4?
Yes, because m is 12 and n is 4. Here's a problem now. When I divide, I get x to the third. But x to the third will not always be positive or zero. So if they hadn't given us this, I would have had to write the absolute value because this is always positive or zero. This must be always positive or zero. The reason why these symbols are redundant now is because they already gave us the restriction. X is zero, greater than or equal to zero. So there is no need for the absolute value. But otherwise, if this were not here, the answer would have required the absolute value, because if x is negative, this quantity is positive, but if x is negative, this quantity is not positive. Good. Okay, do you think we need another example like this, or can we move on?
I was just curious, what's the reason that odd index don't require extra step?
Oh, very good. Because the cube root of -8 is -2, the cube root of 0 is 0, the cube root of 27 is 3.
Okay, I see it.
The cube root exists for anything. I can always find a number, -2 to the third to give me this, 0 to the third to give me this, 3 to the third to give me this. But if I want the square root of -4, I have no answer.
It's not possible because negative times negative is positive.
Yes, because it's not a real number. But with the odd index, there is no problem ever, ever.
Okay, thank you.
Better?
Yes.
Okay, perfect. Very good. Moving on. So do we need other examples or we continue? We discussed the domain of these functions. We looked at the domain of a radical function with index even in this case, because if it's odd, it's all real numbers. Okay. We talked about how to present the domain. Oops, sorry about that. We talked about how to present the domain with interval notation of any rational function. Are we okay with this? Can we continue then? Nobody said anything, so I guess I will continue. If you want me to go back, you can always say so. The final important topic here is something called demand and supply. And this is another super important topic in this class, and it will follow us later on. So the demand and supply functions meet not in the break-even point, but in an equilibrium point. So before we choose, allow me to explain this. Equilibrium point. The equilibrium point is exactly where the demand and the supply meet. Where do they meet? In a point. So here's the supply function, and here's the demand function, and where they meet is the equilibrium point, EP, the equilibrium point. And here's quantity, X, and here is price per unit. So the quantity of, I don't know, 10 items at the price of 3 per item is where everybody is happy. The suppliers will produce at 10 quantities for $3 each, and the demand, we are happy, we are willing to buy a quantity of 10 units at $3 per unit. So in the following examples, and let's choose, we are given the demand and supply functions, and we are asked, find the equilibrium point. Find the equilibrium point for each pair of demand and supply functions. It's good this is just algebra, but this concept will follow us later on. So let's choose a demand and supply function and move on to chapter 1 after that. So 77 through 84. Anything you like, any pair of demand and supply functions will be fine. If not, I will choose.
Can we do 82?
Yeah, perfect. Let's do 82. In 82, we have P equals Q minus 4, and we have P equals Q squared plus 2Q plus 6. Okay, allow me to change a little bit the notation, because this is kind of, I consider it kind of weird. So this is the demand, D of X equals X minus 4 squared, demand. And this is the supply function, S of X, which is X squared plus 2X plus 6. These two functions meet where they are equal to each other, of course, and they create the equilibrium point. So this is my starting point. I set the demand equal to the supply. Find X and then find the Y value. So X minus 4 squared equals X squared plus 2X plus 6. Can anyone expand X minus 4 for us, please? X minus 4 squared for us, please. Remember the pattern?
X squared minus 8x.
Excellent.
Plus 16.
Very good. Thank you very much. Who was that? I was drinking my sip of water, so I didn't see.
Me.
Okay. Oh, before I forget, I have to apologize to you. I was waiting for a student to call me, and I don't have anybody's phone number saved in my phone book. So I have to apologize. I was waiting for Tyler from 044 to call me at 2 o'clock when you called me. So I'm so sorry. It was just a coincidence. Okay. Isaac, I'm so sorry. I had no idea.
That was me.
I know, but I thought it was completely because I was waiting for Taylor to call me. So sorry about that. I didn't want you to think anything. Okay, good. So I solved this equation. X squared with X squared are gone. I bring 2X to negative 10X. And I bring 16 to negative 10. Notice what I just did. I subtracted x squared from both sides, and I separated the variable from the rest. So when I move a term from one side to the other, the only thing that happens is I change its sign. So negative 8x minus 2x is this, and I change its sign because I move it to the other side. 6 minus 16 is negative 10. Of course, I divide by negative 10 and I get x equals 1. So the equilibrium point is 1 comma. I have to determine the y value, which is the price per unit. All I have to do is just plug it in anywhere. They have to be the same. If I plug it here or if I plug in here, I have to get the same answer. Can anyone give us the y coordinate of the equilibrium point?
Is it 9?
Yes. 1 minus 4 is negative 3. Negative 3 squared, thank you very much, Haley, 9. This is the equilibrium point, where the suppliers and the consumers are all happy. 1 unit at $9 per unit. Any questions? Do you think we need other examples, or are we okay to move on to chapter 1 finally? You can always stop me. I can always go back. Okay. So finally, we start calculus today. And chapter 1 deals with something called differentiation. We have a lot to explain before we talk about differentiation. The first thing that we need to look at are limits. And I want you to understand that this is very important. Something, for example, if I want to determine the square root of x, I'm applying the operator square root. If I want to determine x squared, I'm applying the operator square. If I want to determine log base 5 of x, I'm applying another operator called log base 5. And I can continue forever. Well, I'm making a point. What happens if I don't want to take the square root? I don't want a square, and I don't want to apply log. But what I want from a function is the tendency. Not the value. Here's another operator, since we are talking about operators. F of x. This is the value of f at x. But by the tendency, this is something new. We have not seen this in algebra. We've seen the square root operator, the square operator, the log operator, the value operator, but we have never talked about the tendency of a function, not value. This is the value. The tendency, what does that mean? Tendency. Okay, so by tendency I mean find the limit. In other words, tendency. Where is it going? What's the trend, if you want? The limit of a function when x approaches a number, x approaches a, number 1, from either side, Number 2 from the left. Number 3 from the right. So let's recap. I'm talking about the limit of a function, not the value of the function, not any other operator, something totally new. I want to know where the function is going, not the value of the function. What's the trend? What's the target? Target. Better maybe than tendency. When x approaches a from either side, x approaches a from either side. When x approaches a from the left, meaning there is a power, so to speak, it's not a power, but that's how we express it, with a minus, which means from the left, with numbers smaller than a, from the left, with numbers smaller than a, or x approaches a from the right, with numbers larger than a. First of all, you're going to ask, rightfully so, who cares? What are you talking about? I need to know the value of a function. I need to know the square, the square root, the log, but why would I care about the limit? Who cares about the limit? Well, we care about the limit because it's an operator that would give us something else. That's why we care about the limit. And we have to understand these limits. They're a major topic in calculus. So, how do I write this? I have many ways of writing operators. Square root, la 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 la. So, how do I write this? In short, LIM of f of x, limit of f of x, and I have 3 options. This, or this. As x approaches a from either side, limit of f of x as x approaches a from the left, and limit of f of x as x approaches a from the right. Again, what's the scope of this? What are we interested in? Something that follows after this section. That's why we need to understand limits. So we have 2 sections, 1.1 and 1.2, in which we're going to understand limits from graphs and then algebraically, and then we are going to apply the limit to something. And you'll see what happens next. Okay, so I have 3 possibilities to look at the tendency or target, not the value, when x approaches a from either side, when x approaches a from the left, when a approaches a from the right. So there are 3 different things. Before I show you the first graph, question here. When does a limit exist? When does it exist? When do I say it exists? Answer. When it is a number, comma, not a symbol, like positive or negative infinity, and not something called D, N, E, which means it does not exist. So I say the function has a limit as x approaches from either side if I can give you that number. And I say 5 or 15 or negative 100. Limit of f of x as x approaches a from the left exists if I can tell you it's 5, it's 15, it's 29. Limit of f of x as x approaches a from the right if I can say 0, -3, 100. But if I say that this limit is infinity or negative infinity, I'm automatically saying DNE, but I have to write positive or negative infinity. And I'm gonna tell you, we're gonna see in a moment when we write actually DNE. So the limit exists if it's a clear-cut number. It does not exist if it's positive or negative infinity, but we have to write either positive or negative infinity. And it does not exist when I have to write it does not exist. But in this case, it still does not exist, but I cannot write DNE. I have to write this or that. So I enlarged and I printed out an example from the book before we look directly to the book. So here it is. We have a graph. Is it big enough? Can everyone see this? Is it clear?
Yes.
Okay, let me know and I can open the book also. So I want to answer these 8 questions. Let's read. Limit of f of x as x approaches -3 from either side. There is no plus, there is no minus. From either side. Okay, I locate -3. I imagine that x approaches from this side and x approaches from this side. I'm interested in the target of the function. So now I look at the function. What will you say the limit is?
It's like pi.
Indeed. Thank you so much. As x approaches from either side, the target, I don't care if this value exists or not, the target of the function is 5. Perfect. 26. The limit of f of x as x approaches 2 from either side. I locate 2 from either side, and I'm interested in the target of the function from either side. What will you say?
Use a 4.
Excellent. The limit of f of x as x approaches -2 from either side. I locate -2 from either side. And now I have to find the unique number that the function targets. What is the unique number that the function targets?
4.
The unique number that the function targets. Is there one? Can you say anything?
No.
No, you cannot. Because there is no one unique number from either side.
Would it have been 4 if it was approaching from the left instead
Yes.
of both sides?
Yes, it would have been 4 from the left and 2 from the right.
Okay.
So the limit from the left exists is 4. The limit from the right exists is 2. But the limit from either side, they have to be equal and the same, identical, but they are not. 28. The limit of f of x as x approaches -5 from either side. All I need is the tendency, not the value, the tendency of the function.
0.
Excellent. The limit of f of x as it approaches 4 from either side. 4 from either side. Tendency of the function, not the value at that point. I don't care about the value of that point. I only care about the tendency. The limit does not deal with the function value at the point. It only deals with the tendency. The target.
Tends towards 4.
4 is up here.
Oh, that was expelling. I mean 2.
2. Do you all agree with 2? Remember, the tendency means the target, does not mean the function value. It doesn't even have a function value there. We don't care. The limit is only asking for the target. So, as x approaches 4 from either side, the function gets closer and closer, closer and closer to 2, to the value of 2. F of x, as x approaches 6 from either side.
I had a question. So it doesn't matter if it's an open or closed dot or point.
Okay. So remember what we said? We do not care about the function value. This is not the operator of the function value. This is a totally different operator that deals with specifically target, not function value. The function doesn't have to exist at that point. It's about the target.
Got it. For 30, is it 0?
Yes, indeed. Good. So now let's look at -2 from the right. Can anyone give us the -2 from the right? You already told me. Somebody did. -2 from the right is?
It's approaching 2.
Exactly, excellent. And -2 from the right? Somebody already told us.
It is 4, right?
Indeed. That's it. Very good. Awesome. That's it. Any questions about determining limits from a graph? And I just wanted to look at page 112. Oh, there is a chat for me. Okay, good. So we're looking at 112. So I selected this problem. So we worked on 25 through 32. I just want one here, let's say from the graph, when x approaches 1 from the left. 1 from the left. Can anyone give us 1 from the left?